Okay, welcome back.
Sorry,
Carlo. Welcome back, everyone. Now we are moving on to session 2, and Jarmo and Steve, who is online, are going to be chairing this session. So I'll hand over to you both.
Yeah, thank you. Hope this is working, and let me share my screen. Okay, thanks. Very good meeting you all in person, some online. This session is about the scenario forcings for scenario map and including the harmonization processes. Yeah, so my name is Jarmo Kikstra. I'm working at IASA and Imperial College and joined the forcing class team earlier this year. So we'll have a few presentations. First, I'll give a quick update on the status, the plans, and the timeline. Then Matt will take over to discuss lessons learned from a recent project where they did a lot of similar work already. Then hand over online to Steve, who will be talking about the emissions part, historical emissions and harmonization update. Already was given a bit of a heads up in the previous session. Louise will then talk about land use. Then Ben will talk about CDR in the scenarios. And last is Brian online, who will be talking about the scenarios in scenario map and the updates there in the process. There will be quite a bit of time for Q&A for each presentation. And just as an additional to what is already there, in case you find it easy to take your phone and put a question in, also for us to maybe an extra way to keep track of it. And if you want to upvote something, feel free to go to this slide and also put it there. Of course, the chat and the other discussion document are also still available. Yeah, okay, so let's dive in. I will talk a bit about a quick overview of inputs and outputs for what we call here harmonization process, the timeline. Then there will be a short discussion or maybe longer discussion on the on a 2100 to 2125 extension, and then 10 minutes of Q&A. Yeah, so first an overview of the harmonization process. Oh, this is.
Yeah. So, somebody got a speaker on because we can hear a bit of an echo. So can everyone just check your laptops have got the speaker off?
Okay. Okay, very good. So there's basically 4 classes of inputs into the harmonization process. The first is the integrated assessment modeling scenarios, and they have both an emissions and a land use part. The integrated assessment model scenarios model all major emissions, and for each model, they basically only see changes in the scenarios after 2025. And this is set per model, but across models there can be differences due to different historical emissions estimates or potentially missing minor processes in the integrated assessment models. They model regional land use change, but also this is different per model. So what is important is to align with the historical runs of the Earth system models, and therefore you need the harmonization to the historical product. For the emissions part, this is basically the anthropogenic emissions from seeds, the burning emissions estimates, and a few other global data sources that are added for other species. And for the historical land use, this is the LUH data set. And then the output is basically going to be 6 scenarios, each scenario consistent with historical data, with complete spatial emissions, global concentrations, and detailed land use change information. And so across the scenarios, as much consistency as possible is required, at least up to 2023 with the attempt to, and we'll have a more discussion on that as well, especially in emissions, attempt up until 2025 to have the same across these 6 scenarios. Comparing to CMIP6, a key new part of scenario MIP is the new scenario design. In other ways, this emissions and land use harmonization process is, so of those new scenarios, is relatively similar. The start year is going to be of course, much updated. Now will be 2023 or later, whereas in CMIP6 it was 2015. On the end year, as I was saying, we need a recommendation from the users and from this community on how to deal with 2100 or 2125 to have a long enough scenario. The process itself is more automated this time. And yeah, there's going to be new information specifically for the land use side and the carbon dioxide removal along these scenarios. Here's a slide that I actually took from the person sitting next to me, Matt, that basically shows how in CMIP6, the scenarios were taken, top left, and many people will probably know this SSP RCP matrix. These scenarios in the beginning, then moving on to the harmonization part, have these differences between the historical and the starting point of the integrated assessment model trajectories. And this then needs to be harmonized to exactly the same point, such that all of the changes that you see in the future forcing are, of course, because of the scenario itself and not because of differences in historical emissions databases that are used in the integrated assessment models. Then there's two products that come out of this. One is going to the right, is downscaling to the country level to eventually get gridded emissions data, and this is going to be used even more in CMIP7 than it was in CMIP6, as well as the future concentrations and radiative forcing calculated with MAGIC. Yeah, and so the input to that harmonization is these historical emissions data sources here on the right. What is then different is the scenario design. So the top left part changes quite a bit, and as I mentioned, this harmonization process for emissions is now more in a single workflow, and so should be more automated and a bit faster. To move on to a big timeline here, basically trying to get these 6 different parts together. So on the top is the rough timeline for the integrated assessment modeling scenarios. Where we are now, so end of October, is that we have a version 0, very raw first set of these scenarios. Each of the 7 IAM modeling teams that are participating are trying to explore all of these different scenarios, and now there's going to be a process of refinement. First, better reporting, so we have try to get an agreement right now on how to report all of the variables, and then end of the year, around Christmas, will be a V1 update with the final scenarios planned for around May 2025. Then to get the harmonized emissions, you need to have the historical emissions data set, of course, ready, and the harmonization itself. So let's move on. So a first harmonized emissions product to get started with the iteration is planned for at the end of the year as well. This is just to get this iteration going. And so it depends on not just the IEM input, but also the historical emission input and the reporting agreement between the two. And then the final product is planned for around June 2025, which then would, of course, take the newest IEM scenarios and whatever the then updated emissions data sets are, so these V1s. You notice that there is also a seeds data update planned for around July. The question is whether we should be still including this or not. It might be a bit too late for the timeline, and therefore our suggestion is to basically take this up if the process hasn't yet been finished. If then it's possible to still take this update, then we of course can. But if the process, if it would delay the process too much, and if it's already finished, then we're gonna go ahead without that part. What is here, this V2 is basically, that's gonna be the update that would add on the 2024 time step to seeds. Otherwise, it's 2023 as the latest. That also means that the update for harmonized emissions goes into the climate emulators as well, which then provide the concentrations product. And similarly there, you would, if you would update the historical emissions, you would also need to update the concentrations product. Then in a different stream is the harmonized land use product, which is also planned for June 2025, where the current work is on basically iterating over and finalizing the historical land use data set. And note here also that we're in discussions and we try to make sure that the land use change with information is as consistent as possible with the information in the IAMs, also for the emissions that are modeled in IAMs themselves, to try to do these consistency checks between what the implied emissions are from land use change conversions and the emissions estimates in the IAMs. So then moving on to the discussion on scenario extension beyond 2100. So the integrated assessment models traditionally only do scenarios up until 2100, and there was the request earlier to extend this to 2125. Unfortunately, inputs to the integrated assessment models and updating all of these doesn't seem to be possible on this timeline, meaning that the IAM teams, while they would like to do this, probably are going to prioritize doing the other updates, and the runs will be until 2100. The question then is, and we would need a recommendation here on how to continue, is what would be most useful for the community? Would this be to start the long run extensions on a global level, the simple stylized extensions in 2100 instead of 2125, so basically using that? Or would it instead be to try to think about how to do regional and gridded extension, so an extrapolation of the IAM results for those 25 years to bridge that and still have a 100-year long scenario? Note that this would be a new process, and for instance, on the land use side, it might be tricky to try to do this extrapolation for the regional spatial patterns. So definitely would love to hear your thoughts on this. Just a quick then reminder, wrapping up, is the scenarios timeline until December, January is new scenarios will provide an update, and that will also kick off the iteration with the IAM teams on basically the harmonization processes. And at that time in January, the format for the product should be clear for this interaction. Then there is a few months of this iterative process, investigating all the uncertainties and robustness, exploring a couple of different methods to see if we need to change anything from the CMIP6 pipeline. And then in June, the new scenarios will drop, and the harmonization process should then be relatively quick. Thanks a lot for your attention, and let's have a discussion.
Ben?
Yes, I mean, I think it might be useful to sketch out what our options are with regards to the 2125 issue. I mean, there was a strong community request to have the simulations go until 2125, and so I feel like there is kind of three options on the table. One is to do as CMIP6 did, which is, and I was just trying to look up the protocol as you were, but on land use in particular, but there was some idealized land use assumption which went post 2100. The two would be to have a more comprehensive effort for the entire extension period. So bringing in aerosol and land use communities to sort of think in more detail about how to design pathways, gridded pathways, and then the third is to have a bridging period where we feel like we can extrapolate for 25 years, but then we have to default back to the CMIP6. I feel like option two might be most desirable, but yeah, I guess that's the discussion which we want to have.
Yeah, so for those idealized extensions we did for land use, in CMIP6, they were very simple. It was just keeping the land use states like cropland, grazing land constant for 200 years. And there were processes like wood harvesting, shifting cultivation that we kept going at the same rate. So we took regional wood harvest rate and continued that, like, because we needed to, we can't do that in the same location each time. So we would, because you would run out of wood. So we were providing a new spatial pattern. So that was moving around, even though the cropland and grazing land were not moving around. I'm not sure I'd recommend that process for what we're talking about here, because that seems way too simplified and some things were changing, some things were not. I think one thing that's not quite clear to me is whether for this 25-year extension for the land use, would we be getting extrapolated data from the IAM for those 25 years, and then we're just doing the harmonization piece on our end, or is it going to be like those 200-year extensions where we don't get any information from the IAM and we have to sort of come up with some kind of patterns ourselves? I think that's a question.
Yeah, good questions. And unfortunately, I cannot give a straight answer here because it's not entirely clear. What is clear is that we will not be getting a GDP projection until 21-25. And so this makes it very difficult to do the IM projection. Perhaps, but I'm not 100% certain on this. The population providers could do an extension to 21-25. And so that would be then, of course, as a scenario-dependent population changes until 21-25. So that would be one driver, but of course that's not extrapolated regional information from the IAM teams. I think that would probably, well, my gut feeling on this is that if you do this extension of the IAM results, that would be one centralized process. But yeah, that's my gut feeling for this.
Yeah, I would echo Louise's comment that there's probably a few things we did in CMIP6 which I wouldn't repeat again. And I think, Yama, you make a good point that probably going all in one is the thing we need to think about. And I think probably the question for the ESM community is how important or sensible are either constant patterns versus changing patterns for stuff, right? Like, does it make sense to have the same aerosol pattern for the next 500 years to do your extension, or should we do something more sensible that phases out in a more useful way? And probably I'll try and keep it as simple as we can whilst capturing the things we know really, really matter. So I think the last minute tweak we did in CMIP6 was we decided that actually having land use emissions go to 0 wasn't that smart because we're probably still going to be eating, hopefully. So we just made them constant, right? And like, I'm sure we can do better than that, but you can get a lot of really quick wins really easily, and we should try and get those by at least having the conversation, and then we can obviously put a whole bunch of things in the too hard basket, I think.
Yeah. Oh, sorry. Go ahead. Just a quick response on ZAP. Yeah, indeed. It's basically, for the emission side, at least, it's a question on to what extent do regional changes matter for that extra 20-25 years. What was up first?
So, I mean, I think we need to think a little bit about what questions we're trying to answer with the extensions. Like, we've already had quite a lot of discussion, like on the design of the extensions, and like specifically around looking at different amplitudes of overshoot. Like, and I think we have to be thinking forward with these experiments into what they would look like with interactive carbon removal. And so, I mean, my gut feeling straight away is that aerosols probably don't matter too much. Like, we could carry on with a constant aerosol assumption, but we couldn't get away with that for the land use. The land use would have to reflect what is a time evolving, you know, the removals are defined and time evolving, and the land use would have to, at least in an idealized fashion, reflect what's implied by the removals, assuming the removals are BECCS. Whether that's too much of a lift, I don't know.
Thanks. So I don't know if this is a bottleneck on the IAM group side, but it seems like it's necessary to have the GDP and population projections in order to develop the scenarios beyond 2100. And I understand that they don't exist from the SSPs, which is the issue. I'm wondering if there is a way to sort of make simplified extensions for those that could work for scenario MIP. And if not, then I guess we probably want to go back, and this is more of a scenario MIP question, I guess, than a forcing stat team question, but the scenario extension group of scenario MIP sort of come up with these post 2100 projections, and we probably need to sort of reconvene and be a bit more sort of granular in the kind of extensions that we want to consider beyond 2100.
Yeah, I think I'll echo a number of things that others have talked about here. But so the first thing is that, okay, so indeed you need drivers, right, in terms of GDP, but you also need driver. I mean, at the end of the day, IAMs are run based on the achievement of certain global policies, right? So the other thing that needs to be thought about is in the SSP 119 scenario, what is the global policy beyond 2100? And I'm not saying that this group needs to think about that, but that's fundamentally what the IAM groups will need to think about in terms of what are the likely scenario, how to do these extensions. The other thing is that if we want, so I agree with the sort of three broad approaches that have been laid out, which is basically do it as we did for CMIP6. The other is to basically have this be a first class activity, basically, which is how do you extend gridded scenarios. I don't know that we have the impetus for that here. And then the third is trying to figure out, is there a simpler way to do this kind of extension? Based on my experience in this process previously, and also with the IAM groups, I think the best way to see that go forward, if the IAMs are indeed, the IAM teams are not going to provide that data until 2020, 21, 25, to identify a single group or champion who would be willing to think hard about this problem and do that work. So in the case of CMIP6, that was Malta Mainshausen and Zeb and others who said, okay, we will centrally extend all of the IAM scenarios in this concentration space. But I think for this kind of effort to be successful, again, if the IAM groups are not able to provide it, we would need some champion who would basically say, okay, I'm going to think really hard about how to extend at a gridded level over the course of 25 years, all of the scenarios. So rather than kick it off to each of these different teams. The final thing that I'll note is that there will definitely be trade-offs in this process. So one is sort of level of detail. So one of the key benefits we get from IAMs is relatively, although not nearly as high, regional detail, but more regional detail than simple global pathways, right? And so this is fundamentally, when we're doing the downscaling, we're downscaling from what the IAMs have as their own native regions, and that gives us higher granularity in terms of emission evolution at a regional level. So we see China different from North America, different from India, different from et cetera, et cetera. And the question is, one thing that we'll have to figure out if we want to do this is how much does that matter in this extension period, right? Because could we, for example, freeze all spatial patterns and only move to global trajectories? That's similar to what Zeb and colleagues did for the concentrations in CMIP6, right? But we could think about extending only emissions and other activity forcers, such as land use, for example, at a global level, and then have the downscaling processes try to work from that. So yeah, that's a smattering of ideas, but basically I think this group will, or I guess CMIP more broadly, will have to decide sort of how important is this extension and with what level of fidelity are we okay with going in order to get it, basically.
Can we ask Steve online? You've got a question?
I think mechanistically, the population is the key thing that needs to be extended. And we did, actually, Brian O'Neill did contact the folks producing that. We're going to contact them again. They did express willingness to do that, but whether they're able to, we need to figure that out. But once you have population, then GDP, there are some fairly obvious simple ways to extend that. And then you've got the most fundamental data you need to operate either, well, you need that for an IAM for IAM to run, but if IAMs are not all running, then that's still the fundamental data you need for any sort of other type of extension. So that's sort of the hierarchy in my view. But I think the spatial details are less important as we go out. So I think Matt's suggestion just now was certainly something we need to consider.
So I just had a nuts and bolts comment to make, which is there was a call with the land use change and a whole bunch of IM folks, and effectively what's happened is that they've picked up Louise and George at al's land use data set from CMIP7, and they've kind of been working on those things. In the call, it became pretty clear to me that whatever happens in this historical kind of deck space kind of sets the mode then for everyone else to kind of follow it. Is that a fair assumption? And so, I mean, like with Jarmo's slides, for example, things like the biomass burning emissions, Steve's SEDS emissions, all of those things are kind of setting up this pipeline to start. And so I think in that instance, we've actually got a real opportunity of trying to lead kind of by historical example to start off with. It doesn't set you up for what the scenarios are going to be, but it does give us a kind of a technical connection point. So formats and other things that modelling groups then will expect for the scenarios as well. So just recognising that that's something that we've kind of got as an advantage right now to work from. I don't know if it's kind of that relevant or a point that's worth making.
Yeah, so I guess I have a question and maybe sort of a follow-up comment. So this extension for 25 years seems like there's a few different ways we could do this, and it seems to me we're on a sort of a tight timeline, and this seems like maybe additional work that we weren't planning on. It seems also a little risky that whatever we do, it's likely we're going to see some kind of effect in the simulations that is going to follow on from that. Like Matt, you mentioned, like these, if we extend globally, we won't see these regional dependencies, so we won't see interactions between regions. It seems a little. It seems like we might need more time to iterate on this. I know we're targeting June for these scenarios, and so my question, I guess, is I'm wondering, like, these longer term extensions for like a couple of hundred years, what was I don't know what our timeline for those is, and is this something that we want to sort of roll into that time frame? I'm assuming that is longer than the actual time frame for the future scenarios. We have more time for those extensions, and these 25 years, do we want to roll that in so that we actually have time to make sure that we do this carefully? I'm a little concerned about trying to push something through on top of all the other pressures of time that we have.
I hadn't thought about that one. That's a very wise point, that actually you could kick off the scenarios running to 2100 and then you get your extra 3-4 months to figure out what you do about the extensions afterwards, which, yeah, super helpful. I think just on Paul's point quickly, yeah, it's definitely we can get started on the technical side of doing the harmonization now. So that's what Yarmo's already kicked off. And I think for the rest of the forcing task team, we're probably the only ones who Yarmo hasn't mentioned is me. So that's kind of fine. Like we can also start to build off this because we know, like, you can use data that's going to change, but you can get the formats right and you can make sure your pipelines work and stuff. I think, yeah, in CMIP6, just reflecting a bit. So I think there's two conversations. One is like, how do you get to 2125? And the other one is how do you get to 2500, right? And so there's no IAM that's going to get you to 2500. So I think we're going to need a solution for that at some point, no matter what. And so we need to think about that a bit. And I think in CMIP6, I think what happened was, we did one thing to get concentrations to 2500. I didn't speak to Louise for sure. So Louise probably did something different, consistent or not. And I don't know how modeling groups got aerosols out to 2500. I don't know whether Steve provided anything or they just went, take the file and keep it constant for the next 350 years. So I think it was a bit of a roughly consistent, but definitely not exactly consistent. And so if we could find something that was better than that, for this time round, I think that would be good, and we're going to need at least a non-IAM based solution to get us out to 2500. So we're going to have to design that at some point. I think the question really is, whose desks does that land on? And it sounds like there's already a scenario extension team. Is that right, Chris? So it's probably them to start with.
Yeah, there's a part of scenario MIP. There was a there were four sort of one looking at extensions, one looking at high, one looking at low, and I can't remember what the fourth one was. But Ben and I were sort of both part of that, just making recommendations to scenario MIP.
And I think if the recommendations are simple, the work's not that hard, right? Like I can write a constant file for a lot longer, or I can do a linear extrapolation. It's sort of just thinking a little bit about what extrapolation makes sense and doing it at the right point in time, which I think is another good one Louise brings up.
Yeah, if I may just jump back in, I think the suggestion I was making is if we go down that route, then it's probably good to sort of reform and possibly open up that extensions team from scenario MIP to take people like Louise on board. So we have like a really consistent framework for doing this for CMIP7.
Can I just say there's a question from John Dunn online about which proposed approach minimises discontinuity in regional aerosol emission change at 2100. Such discontinuity could really influence regional trend and extremes interpretation.
I think all of them, they'd all have to be continuous, otherwise they don't make much sense. So that would be kind of a non-negotiable criteria of any method, that it has to be continuous, otherwise. Well.
Ben, I think was next. Or was it Matt? Matt, I think it was. Oh.
Yeah. So yeah, I guess 2 points. Like firstly, on the timeline issue. So at the moment, the two of the extensions are in the fast track. That's the way it's put. And so that would still put them on quite a...
We are waiting for scenario MIP to tell us which two extensions should be in the fast track.
Oh, okay. I think that's known internally. I think there is an answer.
I would think it's been communicated though.
Okay, all right.
Yeah.
But I think broadly in this discussion, there's been two ways of two conceptual ways of doing this. Like one is to sort of like top down and one is bottom up, and the top down is to sort of like extrapolate the population and GDP curves, and then the bottom up is to kind of like forget about socioeconomics and to say, well, at this point we're just transitioning into just like thinking about a physical pathway, and we need a land use pathway which is consistent with this removals pathway which we've sketched out like in FAIR. So I think the practical question, and this is probably something we need to go away and think about, is like what additional information do we need in order to make that translation between the negative emissions pathway and like, because clearly the land use is going to be a mix of negative emissions and all of the other stuff. Like what do we need in terms of additional diagnostics from both the IAM and from the ESMs, and this touches on the CDR discussion as well, but and can we do something which makes sense? And if we are going to do it in that bottom up way, sort of like thinking about primarily a physical pathway defined by these removal, these idealized removal curves, then I don't think there's any particular argument for just choosing 2125 then, because if you've got that, if you've built that capacity, then you can do it until 2500 would be my thought.
I was just curious how many Earth system models ran their extensions up to 2300 or 2500 and submitted those simulations in CMIP6, and how much of the data was looked at and published? Is that information that you can gather from your analysis?
I know Chris Jones in AR6 had a figure that had, I think, 9 or 10 models that had done it, and that appeared in an IPCC report, so it's a fairly prominent use case. But he also had the issue that he only could do it for SSP 585 and 126, so we ended up using Magic for all the other scenarios to get something consistent, and he had the hot model problem. So that out of the 10, 5 were ones that were considered too warm. So the projections were shown, but the like assessed ranges, to the extent they were assessed, were based on Magic, not based on CMIP6 output.
Just want to make a point of time because we have a few presentations still lined up. It's very good. I mean, I asked for the discussion. I'm very happy that everyone is chiming in. But maybe let's still do the ones that are here and then move on.
Yeah, I think it was me. I think, yeah. I just had to throw this comment to everyone here. If extensions are linear interpolations anyway, do we really want to pay for the CO2 emissions associated with running models out to that when we're not really providing very good forcings to constrain them in the first place? I mean, isn't that just a perfect right spot for emulators? And we'll save our CO2 emissions for, you know, for a harder problem?
I think again, it depends on the scope of what we do. I mean, I think if we can design land use pathways which are supposed to produce the negative emissions, which are associated with long-term overshoot pathways, I think that's worth doing in Earth system models. But if we're just going to define concentration pathways, then no. Or indeed, if we're going to do emissions-driven scenarios and then have a constant land use assumption, that's not worth doing.
I think it would be really useful. I think it would be really useful to articulate what goes into these things to modelling groups to then allow them to make an informed decision as to how they want to proceed. Because often I think what happens is we produce things that might be wildly speculative, but it's not communicated that way. And then there might be a group that's very scrupulous with their CO2 emissions that wants to be very careful about what they do. And they should be able to make a judgment call to say, look, that is too uncertain. We don't want to spend, you know, a time on that. Rather, we're going to go back and redo the historical period with updated forcings. So I think trying to capture that information would be really quite useful, and then allow the modelling groups to make their judgment calls. Having said all that, you do want more than one model to contribute simulations. Otherwise, there's no point in doing it. So, yeah, I don't know. That's just a comment.
Yeah, maybe just very briefly to remind us, one question is why is this even on the table in the first place? And I remember during the scenario MIP meeting here, also in Reading and at the university, we had colleagues from, I think it was the United States, who said this is actually part of a policy planning process. And so they're providing climate services to policymakers. And so that's another reason. So you ask, why would we spend the CO2 emissions on it? That is one reason. I don't know how well that maps to other policymaking processes, but that there is a climate services element to it.
Okay, thanks. If everyone is okay with that, then I'll hand over to, oh, was this who? Okay, yeah, last one.
Perhaps I just want to emphasize this user perspective, because currently we only have 75 years ahead, which we're projecting. So 50 years ago, we started with 130 years. So it's like the user are asking, why do you decrease your capacity or whatsoever? And there's some climate adaptation measures which has to be taken really for longer times. If you think of kind of waterways planning and all these things, so they do have typically a time horizon of 80 to 100 years. And so we need also to give them planning information. So just to emphasize the need for these kind of extensions.
Okay, great. Thanks, everybody. So yeah, I sort of introduced myself a little bit. I apologize for being a little bit late. My name is Matthew Giddon. I'm a researcher at IASA, the International Institute for Applied Systems Analysis, and did a lot of work together with a number of colleagues around the table and online on CMIP6. What I've been asked to speak with you about here is to talk specifically about a research project I work on called Rescue. And then we also have a companion research project called OptimESM, where we've done work on generating forcing data sets since CMIP6. And I'm going to talk a little bit about some of the lessons learned we have from that. So just very briefly, the core part of Rescue in 2 sentences is that we're interested in climate feedbacks and effectiveness around overshoot of certain temperature levels, and specifically the role of different carbon dioxide removal methods. So in this project, we have 5 European Earth system models running new scenarios from the integrated assessment model Remind Magpie. And in this project, we actually look at broadly five different types of carbon dioxide removal. So that's ocean alkalinity enhancement, direct air capture, biomass carbon capture and sequestration, afforestation, reforestation, and enhanced weathering. And looking at specifically sort of the core research questions around this project, or for this project, is for different portfolios of carbon dioxide removal methods, how effective are they in terms of activity-driven or emission-driven ESM simulations compared to what we in the IAM community are expecting their effectiveness to be. So looking at specific questions at near net zero, zero emission commitment, reversibility of overshoot, how effective are these different carbon dioxide removal methods? And so the overlap here with CMIP7 and in particular with scenario MIP are on these three CDR methods. So specifically direct air capture, BECS, and afforestation, reforestation, and that's what I'll focus the rest of my comments on. Happy to talk in the hallways about some of the stuff we've done with OAE and enhanced weathering. So just to give you an idea of the experimental design, we have 4 key experiments in rescue. The two things that, from an experimental design perspective, is that we have 2 different temperature limits that we're looking at, 1.5 degrees and 2 degrees, with and without overshoot. And the way that we define with and without overshoot in this space is that by the year 2100, both variants for each temperature target have the same cumulative emissions. Right, so we're hitting the same cumulative emissions, and in our current understanding, using the simple climate emulator magic, we basically hit about the same temperature outcome in the year 2100. And so that's what you can see at the top, and then at the bottom there, you can see the different emission pathways where we turn or where we use to different extents carbon dioxide removal methods in the no overshoot and overshoot cases. We have tried to replicate what was done in terms of forcing fields provided to Earth system models in CMIP6 and then go beyond that. And so long story short here, so we still provide all of the data exactly the same sort of resolution. So we're talking about half-degree grids. Again, mostly using the same sort of proxy information that was used in CMIP6. This is coming, basically freezing the SEDS proxy, spatial proxy, so the intensity of spatial emission fluxes at the end of the historical period, and then doing all of the IAM runs on top to get regional dynamics and then downscale those back to grids. On the emission side, we had two key innovations. One is that we did a lot of work on international shipping. So we have new historic and also future shipping lane spatial information based on, this is from the maritime team from Helene Muri and others at NTNU. And then we developed a number of new fields for carbon dioxide removal. But critically, what we tried to do is make all of the new data that we provided input for MIPS and CF convention compliant so that they can then be uploaded directly. So just a note, one of the key constraints that we had in this project is that the ESMs, in terms of wanting to spend our carbon emissions in the right place, we did not want to redo historical spin-ups. And so we froze the historical data in the same place that it was in for CMIP6. We know since CMIP6 has come out that a number of sort of key forces in the historical period have changed relatively dramatically. Sulfur being one of the key examples. And so we came up, the main point here is that we came up with some very basic ways to extend at a country and sectoral level key emission trajectories that we would still consider part of our historical time period. So in this project, we extended from 2015 to 2020 and then started our simulation runs in 2020. So we updated the historical year is the key point. We added a variety of new forcing fields in terms of the what we would classically call the emission space, but now we call the emission removal space. You can see them here in this table. They basically are related to all of the different CDR methods. And there's a couple of things that I want to point out here. One is that we provide gridded CO2 fields for all of these, both for emissions and removals, depending on the CDR method. So if we take, for example, in this case, ocean alkalinity enhancement, to actually do that process, you need to mine rock, either basalt, dunite, other kinds of rock, crush it, and then distribute it either on fields or in the ocean. So there's both a positive emission component to that as well as a negative emission component, and we explicitly split those out. The other thing that I want to highlight is that for a lot of these CO2 emission fields, they're mostly used for verification purposes, and particularly in this project. What that means is that ESMs and their activity-driven simulations are computing their own emissions, right? And the point of us also providing the emissions is sort of twofold. One is to do a sense check. So how close are you to where the IAM is also removing carbon from the atmosphere, for example, but then also to provide these additional fields so that they can be used as external forcings if needed, such that if you then look at our CO2 flux fields, if you were to add them all up, you would get exactly the same total carbon emissions that the IAM ran with. So you have full consistency with the provided data set. Again, happy to go into more detail as needed. So we also had colleagues at PIC, Potsdam Institute for Climate Change, develop a process by which that we can produce also land use and management forcings, building largely on work from Louise and George and other colleagues. There's just two things that I want to highlight here. We added actually three particular management variables of interest. One is a management field for managed forests. So this is the share of managed forests and secondary forests. And this, I think, Louise, gets to this forest plantation issue. So the key point here is that the ESM teams wanted to know basically about harvest rotation frequency. And so now we've split the secondary forest field into high rotation versus sort of normal regrowth, basically. And so that's, again, providing additional information in order to model the removal activities. And then the other key piece here is on the BEC side is that as a share of C3 perennials and C4 perennials, we provide the share of those crops which are being used for second generation biofuels. So that's basically of all crops grown as C3 and C4 per, what fraction of those are being used for bioenergy production. So that's at a gridded level what we've done. I want to note that all of the processing we've done here are with open source tools. So all of the code is open source. We're in the process of further enhancing the documentation and adding more tests. But the point here is that you can go take a look yourself as you're interested. But now nothing is sort of done under the covers. Everything is publicly pushed. And so, for example, in particular, we have three of these repos. One is called Ineris. This is building on some of the tool base that was done in CMIP7, and this is where we have the actual tools for harmonization, downscaling, and gridding of emissions. Then there is the MR downscale tool, which is where the land use harmonization and gridding happens. And then finally, we have sort of a repo which brings everything together. So instead of individual tools all being shoved into the same thing, we then have an open source repository which defines workflows. So you can say I want to use this version of this tool to do this process. And there's a large configuration file which basically documents how we generate the forcings in a way that we can then publish and go back and reference in the future. Yeah, just very briefly, how are the ESMs actually implementing these different carbon dioxide removal methods? Direct air capture, very simple. Basically, it's an externally forced sink. So we grid the direct air capture removals, and that's a direct forcing that the ESMs are using. Afforestation, reforestation is largely coming from the land use management files. Some of the models are increasing their representation of forest-based plant functional types. again, to get these different rotation dynamics. But that's pretty straightforward. I think the one that's been the most difficult, as we can all expect, is bioenergy with carbon capture and sequestration. And I say CCS in parentheses because really we need to first get the bioenergy part correct. And this is where most of the ESM work has been done in the project, trying to add new PFTs for different crop types. Different ESMs are tackling this at different sort of levels. So some are just adding new nitrogen fixing crops. Others are actually adding miscanthus and switchgrass. And basically, different models are taking different approaches based on their availability and what they can implement. And I think as we've already heard, and we will see in this process that ESMs will do the same thing here. Different ESMs will have different capabilities to do the implementation. So just as a rundown, what is the new data that the ESMs are using beyond CMIP6? One of the big ones, we talked about gridded data in terms of land use, and that was this new managed forest and bioenergy variables. But there's a critical value which we also have to add at a global level, which is the fraction of that bioenergy, which is then captured and stored geologically. So basically take that out of your land carbon pools and throw it away effectively. That we define at a global level. As I mentioned, we also have the better representation of C3 and C4 second generation bioenergy crops, the managed forest variable to get the faster rotation information in. And then one of the critical things that we've done in rescue is to explicitly treat positive emission fields separately from negative emission fields, right? And so the point here is that based on what ESMs are able to implement, they can pick and choose which of the scenario forcings they're actually using at the end of the day, but they always have a reference of something that was internally consistent with the scenario. And then indeed, we also added a number of different inputs for simulating CDR interactively. We talked about the bioenergy ones. I'll just mention we also do alkalinity additions in the ocean, and we're working on doing it on field. So that's OAE and enhanced weathering. We can talk about that as we want, but my understanding is that for scenario MIP, that's likely not going to be a removal activity. One of the things that we wanted to look at the beginning of the project, but we ended up not doing, which I still think is very important for this group to consider, are other things that the IAMs are doing in terms of the bioenergy space. So one is that there can be a lot of trade of bioenergy. So you grow crops in a certain region, you harvest them, you trade the biomass to a region that then wants to use it as a fuel or as an input for energy generation, whether that's power or synthetic fuels or others. This is represented in the IAMs well, but the communication is very hard in terms of communicating, for example, negative emissions. So who gets to count the negative emissions? Is it the grower of that bioenergy crop, or is it the consumer who actually burns it and then stores the carbon? In the IAM space, it's the consumer, but in the ESM space, we think about it more as the whichever entity is growing that crop. So that's something that we need to continue to think about. The other is non-physical agricultural yield improvements. So there are in our modeling frameworks, we assume technological change. We assume that we get better over time at growing crops, whether that's by enhancing the effectiveness of fertilizer or other crop rotation methods, for example. And what that ends up doing is it makes, for a given hectare of bioenergy crop land, you can get more and more removals as time goes on in an IAM, right? And this is something that we wanted to tackle in rescue, and we ended up not being able to, given the time and resource constraints we had. But it's something where we know that there's a disconnect, and something that this group, I think, should think about. And then the other two things that I wanted to bring up is issues around interpolation. So we talked about that IAMs provide 5-yearly data. It's not necessarily clear for every IAM framework that the right thing to do to get yearly values is to linearly interpolate. So on the one hand, I wanted to raise that as an issue so that this group thinks about that, but also provide a recommendation, which is that we ask the IAMs to adjust their data as needed such that it's consistent and can be linearly interpolated. Because I don't think it's the job of the ESM teams to figure out, oh, I have a remind scenario, I should do this process. Oh, I have a message scenario, I should do that process. The other sort of lesson learned that we have in the project is that things are either global or they're gridded. So it doesn't really matter for us. So we have a lot of information that we can provide at a regional level in IAMs that is relatively hard to provide at a gridded level. And we did a lot of thinking about how can we communicate that information effectively to ESMs, and fundamentally came to the point that either if we can do it gridded, great. Otherwise, we just provide a global number. So that's another one of these lesson learned, so that other people don't have to think so much about that. I'll end now on some final thoughts. So the first is that we've generated these scenario forcings with interactive activity-driven carbon dioxide removal. Teams are now testing them and running them. So we're doing 10-year simulations to make sure all the data processing works. That process has actually been going on for the last year. So we've been doing iterative implementations with the ESM teams where we provide them a data set. They tell us why it broke, basically, and then we fix it. So just to reiterate, so we added new gridded variables to communicate information on bioenergy crops and other carbon removal fields. We also needed to provide non-gridded information, so other metadata in order for ESMs to make their simulations consistent with IAMs. I want to reiterate that a lot of the CO2 fields that we're generating in this project are for verification only, but in principle can be used for forcing, although we're not necessarily doing that in this project. And then finally, to note that even though we've done a lot of work, there still are known inconsistencies that we might want to try to tackle in CMIP7. Key example here is these technological agricultural yield improvements. But even if we don't tackle them, I think it's useful to sort of elevate that they exist and maybe even try to estimate what that effect may be in terms of the inconsistency. And with that, I'll stop. Thanks.
Okay, thanks a lot, Matt. Paul?
Yeah, thanks for that, Matt. That was really helpful, I think. I just had a nuts and bolts question, which is you've got MPI, ASM, and FOCI that's listed as one of the ASMs that's involved in rescue. Practically, who's doing that? Because the impression that I get is that MPI is not interested in doing scenarios, but this is science, you know, how you actually implement these things in a model. And so where's the work being done? Is it something that DWD is picking up? Is it something that MPI is working on? Like, how do you actually merge the operations with the active science?
That's a great question. I actually have to say, of all the teams that I work closely with, I work least closely with the MPI team, but the team that I do work more closely with is FOCI, right? And so that's Nadine Mingus, for example, David Keller, who recently moved, and then Sabina Krishoff, I believe is her name. But that's the team that we work most closely with in rescue. Yeah.
Yeah, Louise?
Yeah, I just wanted to mention that you, Matt, you talked about the interpolation of the data and how that would be useful for the system models to know how to take the 5-year time step data and what to do with it. And I just was going to add that'll be really useful for the land use data as well, because I feel like I spend a lot of time taking the IAM data and trying to figure out how to get it on the annual time step. And so making that process smooth for the land use data as well would be great. So it sounds like you're off to a start on that, so we can leverage that to make this harmonization work better, I think.
Yeah, maybe if I can just respond directly to this, is that it gets even more confusing because in some cases, yeah, sometimes teams might report variables even in different countries. So they might report a midpoint for some variables, but they might report what is the value of this variable at the end of their time step for others. And I think specifically in terms of developing a scenario MIP protocol, I think it would be very useful to explicitly say what are all of the variables that that IAM teams will be communicating to either you or other emissions land, et cetera, and a guarantee or a check that they can all be linearly interpolated, right? Because I think it's a relatively simple transformation on the IAM side, and they are also the experts of their modeling frameworks, right? And so that would be my strong recommendation, is to have this not be a question anymore, but rather a requirement of data provided by the IAMs. The other thing that I would note is that I think we actually have quite a number of rescue colleagues on the call. So I would invite them to please add to whatever I've said, because even though I'm I happen to be the one giving this presentation right now. This is a huge research project with many, many different people. So yeah, I happen to be talking, but that I'm only doing a small part of the work. So
Yes, so we've got Shraddha online.
Hi, yeah, just to answer the question on MPI, ESM, and rescue. So the work is primarily being done in Ludwig Maximilian University of Munich, in Julia Pongratz's group. I'm the postdoc working on rescue, and I see Julia is online as well, and she can talk a bit more on the community efforts from our side.
Indeed, maybe I can quickly add. So yeah, for CMIP6 and before was always the MPI, the Max Planck Institute in Hamburg, who took care of CMIP simulations. This has changed now for CMIP7. It's more an operational business going to the German Weather Service with a community effort in the individual MIPs where diverse people in Germany are involved. So it's not entirely clear which scenarios will be run, which MIPs will be participated in. But there's the community behind it, and there's the German Weather Service doing the operational model tuning and deck simulations and so on. And for FOSA, indeed, this is something that Geomar will have to answer.
Okay, thanks. Ben?
I guess I was wondering whether there's any scope for simplifying the protocol for a scenario MIP deployment. So in particular, I'm thinking about when you said that like a large fraction of the lift has been on the implementation of bioenergy crops in the ESMs. Was involved a couple of years ago in a sort of in a simple hacky BEX implementation in CSM where you just took a fraction of the product pool and then effectively redirected it to some sort of permanent store, and that was pretty simple to implement, and you gained something from that. So yeah, so my question is, how is there any value in a sort of in an implementation which doesn't require a long period of bioenergy crop implementation for a large fraction of ESMs if we wanted to deliver this, you know, say on a fast track timescale?
I mean, my personal opinion is yes, and I think the simplest thing that can be done is, as you said, so take this global variable which says, okay, of all of the carbon stored in your C3 and C4 perennials, which you represent as second generation bioenergy, remove a certain quantity of it, which you will then which will be prescribed, basically, right, as part of the scenario forcing. And even there, I think you get a lot of the way toward, like, you get a lot of the way towards aligning with the IAM assumptions if you cannot then also sort of implement the PFTs that the IAMs are assuming, basically, and if you also can't implement the yield improvements, right? I would say those are sort of the three axes of alignment.
Okay, thanks a lot. In the interest of time, I suggest we move over online to Steve. Steve, probably you want to share your own screen, I guess?
Go ahead from there. I think that's easiest.
Okay. We'll keep it. Okay, go ahead.
So hi everyone. Yeah, go ahead. So there was a there was a title slide before. So I'm going to talk about three things. No, there was a content that got lost. I'm going to talk about this slide about emission updates. Going to talk about the new scenario process that was previewed in the first talk, and then talk a little bit about emissions height as a very specific potential update. So just on the anthropogenic forcings, talking about those on the left. So the current release, the aggregate emissions in terms of just totals, there were a number of updates from the CMIP6 release, but the updates have been more modest from the previous version released a couple years ago. The biggest thing that stands out is lower global CO and NMVOC emissions. Obviously, those are well, they are quite uncertain. So that's just something that may vary often as we get updates. And the more major updates in terms of gridding is that major point sources are more accurately located. We did an update to seasonality, which incorporates COVID. So you see that on the right for global NOx emissions, not including aviation. So you see there's more detail in the seasonality than there was before. So we use a variety of sources. We use Carbon Monitor for where we have that. So we have the recent years, but some other sectors we use other data. But you see the big dip in NOx due to mostly transportation, passenger transportation dipping in 2020. The next release, which will be at the end of this year, the entire time series will be updated to 2023. One of the things we've noticed already is that the latest IEA energy driver data, there's a lot of changes to biomass consumption in quite a number of countries. So that's sort of an interesting development. And then as Jorma mentioned earlier, we plan for an extension. Oops, that should say 2024, not 2025. Oops, I'll correct that. Which will be in around July, beginning of July, will be anchored to the last historic. So this is an extension. So this will be anchored to the last historical value, presuming that's 2021 in the release from this fall. And this is 0.5 degree data, same format as CMIP6. We also have been releasing 0.1 degree data from 1990 forward, so not so much for CMIP, but may also be useful. On other data sets, other emission data sets, the open biomass burning, we're not anticipating a further update at this time. We'll see, but there's some staff limitations in getting that done. But that's also, in some sense, less critical in that there's large amount of interannual variation. So, one additional year doesn't change things a whole lot in terms of the average. And then the point we're sort of stuck on a little bit is the fluorinated gases. We're exploring several sources for that data. So next slide. So this slide you've seen before. Again, this part at the top is the proposed structure for the CMIP7 simulations discussed earlier. And then to make better use of the CMIP7 simulations, we will also release extension data for at least a few years, as long as it makes sense and is needed, from the 2021 point. So let me go to the next slide to get into this in a little bit more detail. And from here, I did want to talk a little bit about why recent emissions estimates are so uncertain. And these are some of the data characteristics that lead to additional uncertainty. And I'm using the current state in fall 2024 as an example, so I can be easier on the words. So when we estimate now out to 2023, we have energy consumption based on the Energy Institute energy statistics, formerly BP. And many of those 2023 data points are likely to be revised next year. Not all of them very large, but there will be revisions even going back into time. And then we only have aggregate energy consumption for there. We have total coal, some liquid fuel breakout, total natural gas, and only for large countries. So we have to assume the distribution across sectors is constant from 2022 going forward. But we're also extrapolating the sectoral-based data from this IEA last data point in 2022. And that 2022 data may also change in the next IEA release, because that's the last data point there. And then activity data for non-combustion sectors is for the most recent couple years is often not available at all. So we're just keeping things constant. So that's some of the reasons on the activity side. From emissions inventories, or you can equivalently emissions factors, because we're calibrating to these emission inventories. Country level, where we have country level emissions inventories calibrate to that generally lag about 2 years behind. In limited cases, for example, in the USA, we have some emissions data out to 2023 at this point for selected sectors, basically electric power and mobile sources, plus estimates in 2022 for the large point sources, but we really only have complete data for 2021. One of the things that's helped make the data more robust is we have satellite-based estimate of SO2 points, large point sources, out to 2023 at this point. So that's very nice, because that enables us to check our assumptions, check that even though this doesn't cover all point sources, it covers a significant fraction of them. So we can see if there's discrepancies between our bottom up and top down for this important forcer. So that's helped stabilize the data quite a bit. But we don't have similar time series for other emission species, however. And for other emission species, there are different issues than for SO2. For SO2, we've published a paper on the uncertainty characteristics of this. So we feel we understand that pretty well, working some additional work. But one of the points I want to make about this is people talk about satellite data. These satellite data are not like real-time satellite data. They need a year's worth of data to process and do their curve fitting, in part because the SO2 data is noisy. So next summer, we're not going to have, sometime in the spring, we will have satellite estimates for 2024. So that'll be great. And then they'll revise their whole time series. But we will not have any data for 2025 because this methodology, because of the noise involved, you need the entire years of data. And particularly for this species, and actually for a lot of satellite species, if you're looking at data for 2025 in like July, you actually may only have a few months of really solid data because in the winter it's cloudier in the northern hemisphere, and the satellites don't work in the clouds, or at least many of them don't. So we want historical CMIP simulations to stop at a year where the emissions data are relatively stable. And on the next slide, walk through some of that consideration. So this is just a reiteration of backup is just some of the advantages of doing it this way. We're backing up the historical data a couple years from the latest year. This is just a figure showing exactly the same thing you saw before in a different way. But this allows a different time and data collection for refinement past that last frozen year. This will facilitate more robust extensions of the CMIP historical data in the future by using more robust starting points. That's something we've been asked about many times, so we want to finally provide that. As historical, okay, and then of course, as historical data is updated, emulators and perhaps ESMs can evaluate the impact of any data updates and even compare that to when we update the entire time series as well. Next slide. So what end year should we use for the historical simulations? This has to be a compromise between data stability and being relatively recent, right? In terms of data stability, the further back you go, the more stable it is. So we could go back 10 or 20 years and the data is even more stable, right? And it's not that it's less uncertain, it's just that we'd have no further information often, right? But so we don't want to go too far back, but because a more recent year means that there are fewer years with identical forcing data. So we're not duplicating years of simulations. We want to be efficient in that way. But of course, the closer we get to the last possible year, the less reliable estimate would be. So with 2023 as the last year we can provide historical data for this fall winter, we're suggesting 2021 as the last year for historical forcing simulations. So we note that the forcing data will be provided out to 2023. However, my understanding is the historical scenario data submission will only accept data out to 2021. Future scenario data must start in 2022. And therefore, the models can run with forcing past 2021, but we need to make it clear that they must save the restart files for 2021 since the 2022 data will change. So I guess that's just a communication issue. And then next slide. So this is another point that has come up, and there's not a common agreement on this of, yes, we can provide emissions data out to 2025, which is based on by July of next year, which is based on some actual information for 2025 since the year is over. But then the question is, do we want to have a fixed 2025 point across the scenarios or have start the divergence in 2025? So 2025 is not the same. So so a fixed 2025 could be consistent with the IEM data, the GDP inputs, and so on. There is a concern about arbitrary deviations created by the harmonization algorithm. enables more consistent comparisons of data for the IAV community. Land use, some extent that it seems like it's possible to do that, but it's also simplified, of course, as well. And for the emissions, we would have to have some guidance for 2025, then we can use that. So the case for allowing some divergence in 2025 values. Of course, we have no data yet. We will have limited data yet for 2020. Well, I have no data yet for all of 2025, right? We may have some limited data for part of it. So presenting that as a consistent data point seems somewhat arbitrary and could be misleading. This would mean we have three types of data points in the common trajectory, right? We have historical, we have these sort of what you might call fast track harmonized data points across scenarios for 2023, probably 2024, and then this common scenario year, which is just an assumption, but not an actual historical data point. The IAM-based averages are generally not meaningful guidance because the IAMs just don't work on this time scale, and many of them still have 5-year time steps. And there's other variables that are differing between the model. And a point at the bottom, this is really a consideration specifically for CMIP7 and scenario MIP, because in principle, later studies could use updated historical data and updated reharmonized data for other non-ESM analysis, for example, for AR6. But this is particularly an issue for CMIP. But I think the bottom line is whatever is done needs to be clearly and repeatedly communicated so people understand that. So one more topic. And hopefully many of you have seen this paper. We found that the assumed injections height of emissions matters. This is the result from what we called emissions MIP a year ago. So injecting all anthropogenic emissions into the surface layer biases model results for concentration, depositions, forcing, and of course everything that depends on those, sometimes quite substantially. The difference in some models was up to 0.35 watts per square meter of radiative flux. This is not a forcing calculation, it was a flux calculation for those that know about the difference. Just a subtext note that a fraction of SO2 emissions should also be injected into the atmosphere as SO4. So next slide. So there's a recent paper by Guevara et al. Has found that power plant emissions plumes are much higher than assumed in global models. So this is what I call the effective ejection height. So it's the height of the stack plus the plume rise. And many models use the AeroCom protocol, where ENE and IND emissions are injected between 1 and 200 meters. That's shown at the bottom left in the blue on this plot. And there's shown in the plot, plume height varies by region and generally a bit less by emission species. Emissions MIP assumptions were also too low, but they also applied to all SO2 emissions, not just the large sources, so that mitigates that slightly. And just the plot, what you're seeing there is really there's these 5 data points, the 5 percentile, 10 percentile, 50th percentile, 90th and 95 percentile for the plume height, average plume height for each of these regions. And then of course there's a large distribution around that, which is shown for Eastern Europe in the figure below. These are emissions weighted plume heights for SO2. So you see that there's 10% of the emissions can be even above a kilometer, although in most cases it's more like 90% of the emissions are below 700 kilometers. Meters, I'm sorry, not kilometers, meter, below 1 kilometer. But that's much higher than what's being assumed in models now. So this is something to note. So next slide, last slide on this topic, and then we can go to discussion. So what guidance should be provided to models? So this change in input data assumptions would change model results perhaps substantially, and it may be too late for models to recalibrate for CMIP7, because if you're going to change something this much, you would have to recalibrate your model. So that's pretty significant, but there's definitely a bias here. Even if we're not doing this for CMIP7, and that's of course the thing to ask the community, what type of data, we need to think about what type of data should be provided for global models. This This is something that models do in their either pre-processing or the way the emissions are integrated into the models. So this is a significant amount of work to implement this sort of thing. It was in emissions MIP. It was the thing that took all the modeling groups the longest to do because they actually had to change their model processing code. Whereas our other emissions MIP sensitivities were largely just here's a different emissions file to run, which is obviously much easier to do. So the time for this is not trivial. Some considerations, the emissions height will vary across time. So it will be higher in the recent past in some regions before pollution emissions controls when larger tax were used. And then it will be lower into the more distant past when facilities were smaller and didn't have such tall stack. Industrial sector emissions will have even wider range of heights than the electric power sector, ranging from substantial emissions at the surface, say from construction, agriculture, and so on, to much higher emissions from very large facilities, large smelters, oil processing facilities. There's an oil sands processing plant in Canada where the average plume height is 1 kilometer. So those emissions are way up there. And that's an observed value. That's not a modeled value. The fraction of emissions emitted above the surface layer will vary by emission species. So for example, for BC in an industry, almost all that's going to be near the surface because it's from diesel engines. It's not from these large facilities. But for SO2, it's the other way around. A large fraction of it will be emitted high. So there's lots of questions to think about here. So I think is a global average distribution okay, or for large geographic regions, differentiated by emission species, differentiated over time sector. So how much difference in this quantity matters is meaningful? So I think that's sort of the bigger questions. And sort of a more longer term in the red, as model resolution increases, should global models consider incorporating point source emissions data and plume rise parameterizations? You know, I think this didn't make sense in the past, but with some of the simulations and resolution that models are doing now, this may really make a lot of sense, and it may not be maybe computationally reasonable. It's a lot of data handling, but it's not computationally that demanding, I think, in the comparison. But I don't know for sure. That would have to be tested. Next slide. I think that's it for what I wanted to say.
Thanks a lot, Steve. Just in case you want to do a quick vote or so, you can also go to the slide and click on whether you think that fixed 2025 is more useful, even given the downsides that Steve mentioned, or whether a divergent one is more useful. Not sure if a vote will be the way to decide it. Probably not. Discussion is better. So let's do Matt first, and then I saw Ben.
Yeah, well, I mean, I think, Steve, the discussion that you had at the end is very important on plume height as well. And maybe just an aside on that, my understanding is that the only forcing field which has a height value is aircraft emissions, right? Or
right.
Yeah, okay. So maybe that's
well, and just to mention that the plume height is dynamic. It changes by hour, right? It's a dynamic function of the local temperature, wind speed, and properties of the stack. So
understood. Thanks. Yeah, then maybe, I mean, my main point is actually on, as Jarmo brought up, sort of this, and Ben, as you brought up previously, this year that we go from historical to scenario. And I actually have a wider question, which is, how much latitude do we have to have different historical to future years between fast track scenarios and the official full CMIP7 scenarios that will come after the fast track? And can we make one decision for fast track and a different decision for the full CMIP7 sort of scenario set?
It would seem like it, as long as you keep the historical fixed point, right?
I mean, as I understood it, there isn't any plan to do any, like, the scenarios live in the fast track, right? I don't think there was a plan for a second round of scenarios. But it's a valid question, especially in light of the you know, this particular period of time, aerosol forcing, and it is still up in the air. Like there is obviously a scientific need to potentially redo this in a couple of years' time. But yeah.
Yeah, and maybe just to follow on from that, maybe a follow-on question, which is in the same vein, is, are there any other forcing data sets which plan to change from fast track to full CMIP7? Or everything, all forcing data sets are frozen in fast track?
Maybe Paul or Fasali wants to?
That's a really good question. I noted that Gavin got his hand up. So before I respond, I think his hand up, had his hand up for a while. Gavin, didn't you want to chime in too?
Go ahead.
Okay, I'm over to me. That's a really good question. I don't really honestly know. I think the strategy was to try and lock in fast track now and then let science continue. That's not an incredibly good answer, but I think this is obviously something that needs to come up to the CMIP panel and try and figure out what modelling groups are willing to do. I think John's got his hand up, and I think Gavin's got his hand up again too.
So I was just going to say that the scenarios in the fast track are to be frozen for the fast track. All other scenarios are part of the community MIPS, and at their own timescale.
But if you want the comparison to be with historical or pre-industrial controls, then wouldn't you want the forcings to be frozen, at least for the historical, then pre-industrial, and then for the scenarios, especially if you're thinking about extensions, then the 21, extension after 2100 can happen later on, but nothing changes in the past. I don't know if that makes sense.
Okay, then we move on to Gavin.
Yeah. So obviously, there are real imperatives for us to have historical data that comes up as close to the present as possible. And whether that subsequently gets revised, I don't think is so terrible from a modeling group perspective. Extensions of the historical runs are super cheap. There's no spin-ups. We just run another 1 year of the ensemble. And if we need to go back again and then do 2 more years or 3 more years, again, it's not a very large impact on our resources. And so while we have not done that before, and I think it might be a little bit of a psychological shock to the modeling groups, I don't think that there's anything that really prevents us from doing so. And so we would be very keen on having things that went up to the last calendar year, under the proviso and understanding that last year or even the year before may be adjusted as economic data comes in, or this gets revised or that gets revised or something. But we can go back and do that. But we don't want to be in a situation like we have been now, where we're 10 years out from the historical runs, and we have been unable to do extensions at all. And that's untenable if we want to be taken seriously. It's really, yeah, that has to change.
Well, that's certainly the idea.
Yeah,
is to facilitate that happening. I think this brings up 2 thoughts, if I can jump in as speaker. I think one is how often would we? I mean, ESMs are not going to rerun scenarios every year, probably not. But is there? But maybe for other purposes that's useful, or maybe it's every other year. I mean, what's the frequency of sort of reharmonizing and reprojecting with historical data and any other forcings that change? But I think the other thing that struck me, Gavin, about your comment is here we are 10 years out. Do we need a pre-CMIP fast track every 5 years just to say, well, here's another set of historical data updated with the latest science and forcing, and not wait every 10 years to do that or something. I don't know. That's sort of a separate piece, I suppose.
I mean, since I'm on, you know, I mean, having you know, extensions and then updates on a periodic level. I mean, we don't have to. I mean, things can get updated and people can use them if they want to use them. You know, I mean, we've done new scenarios that go back to 1960 because we wanted to include the freshwater forcing that we're working on that you'll hear about a little bit later. And so we're perfectly capable of going back and redoing chunks of the historical period. Now, getting everybody to do that is harder because, you know, everybody has different priorities and different science needs. But you know, we're not. The modeling groups, I think, are far more flexible than we sometimes give the impression. So, you know, whatever is available, somebody will find a way of using, I imagine.
I was just going to chime in here too. I mean, Gavin, like, there is no limitation to modelling groups doing a historical ext or an ASM hist ext simulation with anything they want to do, actually. So technically, we actually have that, you know, that bin there available. One of the things that I'd actually say is I'm very curious to hear from the modelling groups as to what their appetite is to temporarily extend, because you may have different groups that are really interested in putting a lot of effort into a large ensemble, and do they want to, you know, run every single one of those large ensemble members out another year every single time? So it does depend on what the groups want to do. Like, you're speaking on behalf of NASA GIST, and it's really good to hear your perspective. I'm curious to hear from the Met Office, IPSL. I mean, E3SM is a different modelling group to what NASA's approach is too. So I think if we've got enough granularity and the ability for modelling groups to do what they want to do, which is what that historical ext experiment is meant to kind of allow, then I think go for it. You know, if you guys want to run to 2026, go nuts. I don't know where your forcings are coming from, but it is something that we could actually enable.
But that's exactly the point. Like, you know, there's no point in running to 2026 if the forcings are all wrong. Right? If we're trying to answer questions that relate to the impact of Hunga Tonga, or the impact of the marine shipping emission change, or the impact of increasing cleaning up of Chinese emissions, like, we need to have that data. We can't just imagine it.
Completely. But I mean, one of the other things too is that you need that data, and then you need a place to basically put the simulations. And we've got that slot at the moment. The only thing is that it's unconstrained. So historical X for one group is going to be probably quite different to another, and there's nothing wrong with that. But then it's on the groups to say that, you know, my historical X to R1, I1, P1, F1 is, you know, is this. And I think, like, that would be great. Like, NASA GIST, please lead the way, create a template for other groups to follow.
Okay, thanks. So I had Zeb, and then Chris, and then Paul, if that's another one. Okay.
Cool. Thanks, Yama. And I think this idea Steve presents, this historical extension, is super helpful. In the forcings task team, we started using language for extensions, so you don't touch anything pre, let's say 2021 in this case, and then updates where you kind of have free reign to update everything, which means that ESMs, if they want to use it, are going to go and respin up, blah, 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 blah. There's two different modes, and I think a lot of the forcings providers didn't realize they were sitting in one or the other by accident. Like, we do updates, for example. We don't have a working thing for extensions. For us, it's not very hard. It would take about a week. But other groups were only doing extensions. And so realizing there's these two different modes, I think, has been quite a helpful realization for the group. I think coming back to Vishali's question about which forcings do we think might revise as we go through time, given what we've heard today, I think ozone is going to be a massive question mark, because if we're trying to hit go on scenarios in the middle of 2025 and Michaela's telling us she can't deliver till middle of 2026, we might be in a situation where that data set's basically being revised in 18 months' time. And so I think we already have a clear use case of trying to work out what do we do about this for maybe not this session, but a session at some point.
Yeah, thanks. Chris?
Thanks, Jarmo. I just wanted to make the point about the sort of fast track versus community MIPS. So a lot of the community MIPS will be using scenario projections. So DA MIP, RF MIP, for example, will take what scenario MIP do for future projections and use those to run attribution experiments. So if there is sort of an update to the historical beyond 2021, then there's a possibility that some of these non-fast track experiments might be inconsistent with the scenario MIP protocol. So that was my kind of first point. And the second one is I kind of also want to kind of agree with what Gavin said about sort of recent updates being really important. So I'm part of this project called Indicators of Global Climate Change, and we're basically trying to annually update forcings, more sort of globally mean rather than sort of gridded. But for us, it's kind of really important to have really updated data with the proviso that that recent years could change. So I'd really support that.
Okay. Yeah. So maybe just to bring back in on the first point, I think at least the question now for me and Steve and others in the emissions harmonization part is basically when there is a harmonization and then so the harmonization will be fixed in 2023, right? So there's a common point across all the scenarios. The question is, do we also then try our best to create a common scenario point for 2025, knowing that later when new seeds data comes out, that this is going to be different. But for the scenario MIP, at that point, it's already off to the races, right? It's already going. And the question is that useful, that 2025? Because it might be a somewhat informed guidance, but someone then needs to provide this guidance, right? The IM teams cannot provide this. They estimate, but this is not to be used for a central point. So basically, this will take time, but is that useful to have then a 2025 estimate, even knowing that later it's going to be wrong when the ESMs are already running it? Or do we then live with the inconsistency between the high and the low scenarios, where it's a tiny bit? And just bring this back. And I have two, and don't know the names yet, but Michael Tjernström is first. Sorry, Ben, did I miss you? Also for Sally, huh?
Mine was just a quick one. The discussion before about having the forcings available up until 2023, but them it being at the modelling centre's discretion as to whether they were run or not. I was wondering whether it would be useful to have more centralized guidance to run those, because that would be informative about potential biases which emerge during the harmonization process. I mean, I appreciate everything about not being as confident in those years, but would having a wider sample of model response in that period be useful? Would it be useful to have to request both the best estimate historical forcings during that period as well as the harmonized forcings?
I'm not sure I understand the difference. I mean, the harmonized forcings past 2021 would be our best estimate.
Right. Yeah, no, it's possible that I don't understand, in which case that's fine.
But I'm not sure how much value for ESM simulations for a couple of years are going to be pretty noisy, so I don't know what we could derive from that. But I had a different comment, so I'll wait to be called on in my turn.
Okay.
Yeah, so I'll just come in because Paul was looking for other modelling centres' contributions. So I would say, yeah, from the Met Office perspective, I think obviously having the updated forcing data to the more recent periods is obviously always of value, and so I kind of agree with Gavin in that state. But clearly understanding the uncertainties in that forcing data is key, and that's really important that we understand that. So I kind of like the idea of that you separate it as two different experiments, so that it's so you mightn't be part of the fast track, but the modelling centres could choose to run that extension, but maybe hold the data back, but use it to have a better understanding ourselves and feed into other scientific questions. So it comes down to the key science questions that we're looking to answer. But I think having the data there, even if it's got
you know, an uncertainty, a larger uncertainty bound around it is always going to be of value. And we'd welcome that, definitely.
So I was going to change topics, but if you had something.
Well, I wanted to change topics. I'm happy to go now if we've done talking about this.
First.
Just sorry to break the spell, but I want to remind you that in a couple of days' time, we'll be talking to other users. And I'm just seconding what Gavin was saying and bringing it back on the agenda just as a placeholder, as you were. We are going to hear from people who provide services and who do run these models outside the CMIP framework, and they will increasingly so. So I think let's keep an open mind, if nothing else.
So I had two questions. One on the injection heights. So Steve, that's very interesting. And of course, the emissions MIP has been very helpful to understand what the responses are to the different injection heights for anthropogenic emissions. This is something that we also, like right from maybe 1990s for biomass burning emissions, we've injected using certain prescribed injection heights, but now with the models advancing and including interactive fire emissions, they have their different plume rise models. And of course, that enhances the diversity across the models in the model responses. So this would be something that we'll see with biomass burning, but then adding on also anthropogenic emissions, it's going to cause mayhem. At least for this round of CMIP7. But my question was, are there any studies that have performed a historical simulation with anthropogenic emissions injected for SO2 especially, or any species? So that's one. The second question is, do you anticipate any change in the workflow that you have for SEDS emissions development after recommendations from the AR7 special report on SLCF emissions methodology?
So on the latter, no. I don't anticipate it. I mean, yes and no. I mean, no in terms of methodology. I mean, if that report comes up with new information, which it may well do, obviously our group, Edgar Group, Gaines, everybody will benefit from that and update accordingly, as well as they're updating other assumptions. So, so that's sort of a yes and a no. I'm not aware of any historical, well, I know that some models use, for example, the AERCOM specification for emissions at height. Because of the cost, I'm not aware of anybody that's done a full historical coupled simulation of with and without emissions at height. That I don't think has been done, because that would be expensive. I mean, that's why we just did it for atmospheric only in emissions MIP so far.
Steve, do you also want to provide your input?
Yes, on the 20. Oh, go ahead. Somebody else?
No, go ahead.
Okay. Yeah, just back on the 2025, fixed 2025 question. I think that in large part, I mean, I think this makes no difference for ESMs, because we're going to provide them with gridded emissions and they're going to run, right? And whatever changes are in 2025 will be so well within the noise. So that would be my perception of that. But as Yarmo, you've mentioned, I think it may matter much more for other groups. I think on that question, we probably need feedback from some of the impacts community and other users of the scenarios on that a bit. But then the other piece, of course, is practical, and you can speak more to that. I think that one or the other of those options might be easier to do, and given the person power constraints we all face, maybe that may be the default, because, well, okay, we can do this more easier and robustly and explain it, and that's what we do. So just those two additional considerations.
Yeah, just quickly jumping in on that. Basically, the fixing 2025 is simply more work, because it require some guidance because, right, I mean, we're talking about trying to fix a point in time that hasn't happened yet, right? This is mid 2025, trying to see what 2025 will be. So this is a bit beyond what was done before. It's not just extending based on proxy data, it's extending based on something that you don't yet have. Might have some guess, right? But that needs to be provided from outside the IAM community. The IAM teams cannot guess this. Oh, they do provide an estimate, but this is not to be used for the harmonization. So that is more work. I think that's clear. I see Paul is still there.
Yeah, I was just going to go back to the original discussion, which was about 2021 versus 2023 effectively. One of the realities, I think, is that whatever forcing data sets and the temporal extension that is provided is going to be produced, like modelling groups will use those to run out to whenever it ends. So for argument's sake, if we all had forcing data, no matter how provisional or uncertain it was, that extended out to 2024, we're going to get historical simulations that are 1850 through to the end of those forcing data sets. Now, do we want to label uncertain historical wobbling end of the time series something that gets the brand of historical that everyone downstream is going to use irrespective of the quality of that, how well it's anchored or not? Or would we prefer as a community to make a decision that we are stopping in 2021, and then if you want to go and use these data sets, then you can go and you can do it, but you're explicitly identifying that as a historical ext or an ESM historical ext, which then means that we send a pretty clear message to communities that are not well communicating with us at all, that are downstream, that if you want to go and do something with data that we're pretty uncertain about, you've got to go and do something actively, which is go and splice these things together. And the fact that we're actually harmonising the scenarios on the end kind of means that you've actually got to go do something different. To me, that's a better situation, which we don't have to communicate as clearly. And then, as I said, it enables us to catch stuff as we go in this historical ext. It's up to basically modelling groups how they want to do that, but I think that is a far cleaner option, which means that we then label something that is uncertain differently. And then from a nuts and bolts point of view, when it comes to, say, Steve, for example, Steve could generate a provisional data set that actually extends from 2021 through to whenever he wanted to. And it makes no sense to go into time that doesn't exist. But that'd be, say, 2022 January through to, say, 2024 December. We label it as provisional, however we do that. And then Steve can just mint one of those things every 12 months if he wanted to, with those things becoming more stable over time as you look at them, and also giving us this opportunity for modelling groups to do what they want to with clear guidance that you're doing what you want here. I'd be very curious to hear Jane's feedback, Vishali, John's feedback, and Gavin's feedback on that idea, because I think that then gives us the granularity that we need, and everyone can make an informed decision as to how you want to spend your CO2 emissions running these simulations.
Just process point, would it be useful to put that into the discussion document and then we move on to the next presentation? Yeah, is that okay, Claire, also? Yeah.
Yeah, just to respond to that, I think I'm making a similar argument. This is a user requirements question fundamentally, and there are, for the CMIP fast track, it might be very important that you have that reduced uncertainty. There are other communities where the up to the minute, but you can put up with more uncertainty, is something that we should also provide. But let's be clear about which user groups have which requirements and go from there, right?
It's not just user groups, it's actually modelling groups that have different remits. And so, I mean, like ultimately what we're trying to serve with the fast track here is CMIP modelling groups. And then there will be subsequent folks that do other things. That's great.
From the perspective of an observationalist, modelling groups are also user groups, anybody using the data. So I think that's a semantics issue.
Okay, thanks a lot. So we have 3 presentations left. Sorry for we're a bit late on time. I'll hand over to Louise. Louise, do you want to share yourself or should I click?
Do you already have the slides there? I can use those ones then. Okay, so land use harmonization. I think we're a little short on time, so I'll try to speed through it. my overview is that I'm going to give some background on how we've handled land use harmonization previously, just to kind of set the stage for what's changing for CMIP7 and what's staying the same. And then we'll talk about the plans for harmonizing land use data in CMIP7 and what our next steps will be. Thank you. So we've been doing the land use harmonization within our team since CMIP5 when we made land use harmonization version 1. Back then, the historical product started in 1500, went to 2005, which is when we harmonized with 4 different future scenarios. We just had 5 land use states back then: cropland, pasture, primary land, secondary land, and urban land. And we computed all the associated transitions with those states, including wood harvest and shifting cultivation. My figure has, sorry, covered up some of my words there. So we're also computing the secondary age, area, and biomass. So this product was half-degree resolution and annual, but within each grid cell, we have fractional content as well. This was used in Earth system models, and as far as we know, the Earth models were able to meet the metrics and diagnostics that they were looking for with the land use data. So I think this was considered to be used successfully in those models. So next slide. For CMIP6, which was the last big update we did for land use harmonization 2, we started in 850, so we could, so the data could be used in PMIP, PaleoMIP. We went through to 2015, which is when we harmonized with 8 different future scenarios. We had 12 land use states. So we subdivided cropland into 5 different crop types. We subdivided grazing into 2 types. We have primary and secondary land where divided into forested and non-forested, and then urban land as well. And we still computed all the transitions associated with those 12 types. And then for the first time, we also added in land use management variables. So we have irrigation by crop type, fertilizer by crop type, flooding for rice, and bioenergy crops. And that was at 1/4 degree spatial resolution. All right, next slide. Okay, so since CMIP6, we've been continuing to make updates to LUH2. First of all, on the historical side, we provided a couple of alternative historical reconstructions, a high and a low, to kind of help bracket uncertainty and sensitivity. We've extended the data annually for use in the global carbon budget and the trendy models, using new data that's available to fill in those newer years, but also going back and correcting any data errors or providing new data to really better specify the land use change happening in key regions of either uncertainty or of importance for the global carbon cycle. So Brazil and Indonesia and China were the main countries we've updated data for there. The extensions to those the historical land use is just a simple linear trend extrapolation. And so the historical land use data has always had this built in, that like the land use data is not based on observations throughout the whole time series. So we have a lot of modeling and simplifying assumptions to extend the land use data to the current time period. We've also been doing a bunch of future scenarios for the Llama Climate and the CMIP3B projects. We have about 50 new scenarios we've produced for them using the same LUH2 historical product. So those scenarios are being harmonized in 2015. So I think next slide. So for those that are interested in our methodology, the first step is always to engage with the integrated assessment model and scenarios community to try to achieve a consensus on the data that we're harmonizing. So that includes how we're actually defining these variables. You might think that cropland or grazing land are well defined, but they're not, and different groups treat them very differently. So getting a consensus on what we're harmonizing, the data formats, and then the initial condition and the historical endpoints. So we have the historical land use data, but the integrated assessment models don't necessarily use that in their process. So we often find a pretty different set of values in that harmonization. Yeah, so the more that we can agree on that, the easier the harmonization is. So that's sort of the goal. So we spend, I would say, a lot of time in this engagement piece here, and that really helps the harmonization. Then we do the pre-processing of that integrated assessment model data into this common data format because each model has a very different output format, and to run it through our harmonization, we need them all to be consistent. So this is another place where we spend a lot of time getting the data into the same variable names, resolutions. Often there are variables that are not included in some IAM outputs. We have to do some gap filling. Sometimes we will use data from one IAM in place of another IAM, like wood harvest is an example of that. One model in CMIP6 did not do wood harvest, so we took wood harvest from a completely different model and substituted it in. I think in CMIP6, urban data came from one model only for all scenarios. So there's like all these pre-processing steps, which is another time intensive piece. Then we do the actual harmonization, where our goal is to preserve as much data from the IAMs as possible. We do that by applying changes to the end of historical data. We aggregate to 2 degrees, we apply the changes, and then we downscale to 1/4 degree after that. For some variables that are provided at regional or national scale from IAMs, the harmonization process is doing the actual spatial patterning. So wood harvest is an example of that. And then we also do this, the calculation of all the transitions and the secondary age, etc. And then we do a diagnostic check at the end. All right, next slide. So there have been a lot of discussions recently on land use harmonization, sort of getting ready for these next steps. So within Scenario MIP, we had a task team that focused on carbon dioxide removal and IAM ESM interactions. So that's where we really started talking about some of the land use variables that are going to be shared between these processes. Obviously, we have the Forcings Task Team Harmonization Working Group. And then recently, the Integrated Assessment Modeling Community and the team from Rescue that Matt mentioned came together to sort of have a kickoff meeting to discuss how the land use harmonization will work. And I think there are different groups that are starting to develop their own harmonization methodologies. So there was a discussion about which of these tools would we be using. And I think the consensus at this point is that we'll continue using the existing methodology since it's a known format and a process that's likely to be successful given the short time frame, and that both the Earth system models and IAMs are familiar with. But I think it would be great if we can actually leverage all the knowledge and tools that are being developed by these other teams to help develop these common protocols for dataset delivery and to help maybe share some of that workload in advance. I mentioned the pre-processing was really time intensive. So I think this is a place where we can work together with the methods that are being developed by the rescue team and other groups to try to make that piece in particular a quicker process and a more consistent process. All right, next slide. Okay, so our timeline is between now and the end of the year, mostly focused on finalizing the historical data, which is going to provide the initial condition for harmonization, and it will set the format and resolution and variables of the data we're trying to harmonize. We're going to simultaneously be preparing for harmonization during that time by creating a land use harmonization working group that will include people from each modeling group, so we can discuss to start that engagement process, like working with the groups, making sure that we're in agreement on different variables that we're going to harmonize, and then developing a template for land use data that will be passed from the IAMs to the harmonization process. And then next year, start the actual harmonization itself. I don't anticipate that we're going to be making many changes to the harmonization algorithms, which is going to really help, but there will be some new variables in there that we'll need to harmonize. So that will be the only piece of new development. And then I think by June, we'll receive the final scenarios and complete the harmonization. All right, next slide. So the potential challenges I see are just, again, the consistency between the IAM outputs and the consistency between the historical land use data and the IAM scenarios in that harmonization year, and then just the short time period that we have. And I think our solutions are to try to keep as many of the algorithms and data formats the same as in CMIP6 and just start that engagement piece early and work so that we can work closely with the models for consistency and to share that pre-processing workload. I think that might be my last slide. Yeah, thanks.
Thanks a lot. Questions? Matt?
Yeah, thanks, Louise. Great presentation. Yeah, I guess I have two questions broadly, let's say. So the first is that you mentioned that you actually do a lot of work translating what the IAMs give you into your common data format. And I'm wondering does it make sense to actually ask the IAM teams to do this? Because, this is something where, I know myself as an IAM modeler, but also from the community, there's always this idea of, I want the data that I provide, how that data is interpreted to be consistent with the model run that I did, right? And so, especially also as doing all of the harmonization work on the emission side, we actually spent most of the time, I have to say, in CMIP6 going back and forth with the teams to say, here's how the process worked. Does this accurately represent, from your perspective, what your model is doing? And at the end of the day, we push a lot of that work in terms of making sure that the final product is consistent with the model onto the teams, right? Which I think was a useful approach. So maybe that's the first thing. Is that possible at all?
Yes, I think that's what I was alluding to with the development of a common data template and data format. I think if the IAM teams could get the data into that required format before passing to us, that helps not only in our workload, but also in the making sure that the data is consistent with the scenarios as they are intended as possible, so that we're not making changes on our side that are inconsistent with your intentions.
Definitely, I think that's a great idea. And then the other question I have is, again, with respect to the historical data versus the scenario data, because one of the things that, we've talked about this bilaterally, but also amongst others in the group, is that it could very well be that the scenario data, both for emissions, I suspect that we won't have any historical carbon removal fields in the seeds data set, or if they are, maybe you do biochar, Steve, for example, right? But I think there will also be the need for different information in the scenario forcings than there may need to be in the historical forcings. And so my question is it possible to have that discrepancy? So to add new fields in the scenario forcings?
Yeah, so I think we've tried to anticipate what those different variables would be in the for the land use in the scenarios, and to incorporate those into the historical data, where they would just have zero values. And I'm assuming that from an Earth system model perspective, it's convenient to have the same set of forcing variables in the historical and the future scenarios. We could potentially add additional variables into the future scenarios, and then they just wouldn't have a historical component associated with them. And I guess that's maybe more a question for the Earth system models, how tricky that would be. Again, for the CDR variables we have in the historical period, we have added in, at the moment they do literally have zero values, but we have afforestation. We have, you mentioned in your presentation, Matt, the given the fraction of C4 perennial and C3 perennials being used for second generation bioenergy. And so we put that into our data set as well, along with the fraction being used for first generation bioenergy. So hopefully we've captured some of that stuff and we won't have to have different variables in the future. But yeah, I would like to hear from the modeling groups about how bad that would be if we did have to do that. And another place we could add it in, I think, is not just in the land use states, but in the land use management. Sometimes it could go in there. It might be an easier place to add in for some of the groups. So thanks.
Okay, thanks a lot. I see Steve with a hand up online.
Yeah, sorry. Yeah, I put this in the Google Doc as well. In terms of other fields, I think cement remineralization is there historically. We don't track that, but it's in Global Carbon Project. So that's one we need to probably think about what we need to do about that.
So what was the variable?
Cement remineralization. So it's when cement or mortar takes up CO2 as it hardens. And that's now a field in the global carbon budget, and it's treated as a piece of land use, basically, because it happens on land or in buildings. So that's just something that I don't think is in any of the protocols or data anymore that we're considering, but it is a piece of the carbon budget that we're missing. I don't think it's in any of the simple carbon climate models either. So just to put that out there is something that is sort of a loose end.
Okay, thanks.
Okay, any other questions? Otherwise, thanks a lot. And then we move over to, I think it's Ben. Yeah.
So I'll be quick. You can change the slides because I think really we want to just raise the discussion here because projects like Rescue are technically have put in more work on this than anyone else, and so we just need to come to some collective decision about what we take on in CMIP7 for BECCS, if anything. Or whether it's best served by sort of by satellite activities like Rescue. So there was things which have happened is we have a fairly detailed survey of BECCS implementation in various different Earth system models. What this showed was like there's a subset of CMIP models who have between 6 and 10, depending on how you count it, who would have ambition to do some sort of like resolved BECCS simulations in CMIP7. But they are in different places in terms of their technological, or in terms of their process development. A quarter of models have the capacity to resolve BECCS specific crops. But close to surprisingly high numbers reported that they would be in a position to represent carbon storage pools and yield improvements. And so clearly a protocol would need to find some common ground in between the 6 to 10 models which will be interested in doing this in CMIP7. Next slide. So this is just a plot from the emissions-driven perspective that we put together last year, which just illustrates that this could potentially have a huge implication for large overshoot scenarios. So this is just a difference in the crop harvest as simulated in Remine for the SSP 534. In CMIP6 and then the total crop harvest in 3 different Earth system models. So very different order of magnitude and big differences between the Earth system models. So we have reason to suspect that at least in their current implementation, there will be a high degree of variance in terms of the implemented negative fluxes. Next slide. So just to talk briefly about, so the current scenario emit plan is to not implement process-based removals, but that still requires some sort of common understanding about what is represented in the IAMs and what is represented in the ESMs. So as it stands at the moment, the IAMs calculate internally the land use and the yield and the associated negative emissions and accounting for losses in capture and for improvements in yield over the course of the simulation. The ESMs will be handed the net negative emissions, but they will also contain the associated bioenergy crops, which were originally in the IAMs were associated with BECCS. And so this requires some careful accounting potentially. Next slide. So because we have this problem that if the entire life cycle emissions of the carbon capture process and the crops associated with the carbon capture process are represented within the negative emissions flux, then should those crops be represented in the ESM at all? And do we have enough information to in the diagnostics from the simulations to be able to assess whether this is a problem or not. Next slide. So there's a few different ways that this could be addressed. One is to modify the land use data set. One is to internally modify the IAM negative emission flux, or to correct this post hoc, or indeed, obviously, to explicitly resolve the carbon capture. Next slide. In terms of diagnostics, there's been an ongoing discussion about better, in the context of having emission-driven scenarios, having a better breakdown of ecosystem fluxes, both in land and ocean, and in further information on breaking down the product pools. There's potentially some additional fields which would be needed in order to assess what the potential post hoc corrections would be needed on the ESM side. So one is the flux of the product pool to decomposition to the atmosphere. But also the fraction of the crops from the IAM side which were used for BECCS production. Next slide. So so process resolving. So this is process resolving BECCS. This is what projects like BECCS are trying. Projects like Rescue are trying to do. Where in the ESM there is a represented sequestration pool, which could potentially be the destination for both BECCS and other forms of carbon capture. This requires additional information from the IAM in terms of specifying what fraction of bioenergy crops are associated or will be stored. And this is a field which would need dimensions of PFT and location and time. Next slide. So if CMIP7 was going to contain some sort of BECCS MIP, what would it look like? There's a range of potential options here. Perhaps the lowest resistance option would be to simply expand the rescue protocol to a wider MIP, to a larger number of models. A middle of the road option would be to adopt some of the protocols within rescue, which have been well thought through and adapted to the scenario MIP pathways, or finally to attempt to incorporate it into the resolve BECCS into the scenario protocol with its with a protocol design from scratch. The timeline here is probably relevant. One could imagine activities happening post AR7 cutoff, for example, with a more light and fast activity on the timeline of the fast track. Next slide. So now let's get the next slide again. Briefly want to talk about yield increases, which Matt brought up. So in IAMs, there's generally an assumption over time that technological yield can increase over the lifetime of the scenario. The question of how to implement this in system models is an interesting one, which is worthy of discussion. The land surface model has to, at the very least, conserve quantities like energy and carbon and water, and so so yield increases would have to be represented within some plausible framework. So how should this be done? Should this be done by adjusting parameters within the crop definitions over time? what are the technological, what are the practical difficulties in having non-stationary PFT definitions which evolve over the simulations. It's as Matt alluded, this is not a trivial problem, and probably not one which can be solved on the fast track timescale. Next slide. Next slide again. Yeah, so there's two discussions here. The first is how do we deal with the scenario MIP protocol as is, in terms of potential conceptual differences between the way the CDR is represented within the integrated assessment models, and how and whether there's a risk of double counting with the land use emissions which are implicitly associated with the BECS crops in the Earth system models. And then the wider discussion of what should resolved BECS look like in CMIP7? Should we be providing forcing data sets in the context of scenario MIP which allow BECS resolving simulations to happen at some point, and should that be happening now? Is the protocol as laid out in rescue universally acceptable? Could it be simplified? Should it be made more complex? Should we, to what degree do we need a homogeneous representation of bioenergy crops within the Earth system models, or can we have some sort of simplistic representation of BECS where carbon is simply taken from the product pools which already exist in the land surface models, sometimes often without reference to any particular plant functional type, and then yield increases. How can they be represented in ESMs in a way which is physically consistent with the rest of the model? I think that's all I wanted to say for now.
Thanks a lot. Very dense. Perfect. Any questions on CDR?
So on your first discussion point about do we need to modify this protocol to prevent the double counting? In CMIP6, I think, wasn't there already a solution for this? There was, I think, some models doing emissions-driven simulations with CDR that didn't resolve the BECS processes. So is that protocol suitable or not?
Say that again, in CMIP6.
So we had bioenergy crops that were provided in the land use data. Mm-hmm. And then the models used those. They were given the emissions associated, or positive or negative emissions associated with those crops. They didn't compute them themselves. And they, I believe, didn't do this. They weren't double counting. There was a solution in place at that time. So
I mean, if that is,
I mean, I don't run one of these models, so I don't know what the solution was, but I assume that they had thought that through if the data was provided for those crops, and but the emissions were still being provided elsewhere. Yeah.
I'm not sure how that's possible unless you tag which crops are associated with, but maybe we just take this offline. If this is fixed, then great.
Yeah, I mean, I don't know what was fixed. We did say what fraction of the crop types were used for bioenergy. I don't know that we had like a really great spatial pattern for that, but Matt maybe is going to be able to chime in and add some useful information.
Sadly, I will only be able to add to the confusion, which is, so just a point in terms of what we did, and Steve knows this very well because he and his team also were the ones who implemented it. But fundamentally, so the emissions and removals from bioenergy use in the energy sector broadly, so that's power, transport, and other sectors, those were included in the CO2 emissions that were processed, so harmonized, downscaled, et cetera. So on the one hand, then therefore to be consistent, then the ESM, the land surface components of the ESMs must have taken, like if it were to be consistent, then they must have removed them. But then at the same time, my question would be, what about the biomass which was grown and not sequestered, right? Not sure exactly how that was treated.
Right, which is a non-trivial fraction of the total, right? That's a
Depends on the model and
Yeah.
scenario, but generally, yes.
Yeah.
But I don't think we're going to solve that now. Maybe we take that offline.
Yeah,
and-
we need to work out what happened last time. Yeah.
Anyone else? Also, so Matt, a new one.
No, just very briefly, you asked a few questions here, and I'll provide my opinion just to have it in the record. Should we try to, if I can say, future-proof scenarios for being able to do activity-driven runs with BECS? I would say yes, so that we don't have to come back and revisit it later. So even if we don't do them as part of the fast track, if we want to do a BECS MIP or whatever in the future, I don't think that we would then need to have to reprocess all of the scenarios again to add some additional component. I would say if we can avoid that, let's avoid that. In terms of should we implement the rescue protocol, it sounds like even from this discussion, actually most of the land use information is already being added to the new version of LUH. And so then the main thing would be to make sure that we have actually the emission activity and fields from the emission side, which I think is trivial. So I would say we basically are most of the way there already in terms of having scenario MIP conform in most ways to the data being provided in rescue. And then there was a third point, which I forgot, and so I'll end. Thanks.
Luis?
Yeah, no, I mean, agreed. I think the only thing which is going to be absent is the fraction of crops which will be sequestered, right? That's where we want to be consistent with what you did.
So exactly, and what we ended up doing is providing that as a global number, right? So it's basically, we said, if 60% of all of the bioenergy grown, harvested is then sequestered, then that's a global variable that then ESMs are assuming that in every region. And that's, among other assumptions, roughly fine, basically, in terms of not having it regionally distributed. And so, yeah, and that's basically what we would need to add, indeed. But then I would say actually the hard part is what we've both talked about, which is the other aspects of what IAMs are assuming, which are not being communicated through other forcing variables, such as agricultural yield improvements, trade losses, yeah, these sorts of things.
I mean, in terms of what needs to be, if what we're doing here is future-proofing, rather than attempting to run simulations in the next year, then there just needs to be some agreed way of communicating what the technological yield increases are, and then how the Earth system models interpret that is a question for our future selves.
Okay, thanks. Luis, did you still have a?
No.
Okay, very good. Then thanks, Ben. Then we move on online to Brian. Brian, do you want to share your own screen or shall I click again?
You can go ahead and share them.
Okay, go ahead.
Okay, great. So first, this has been an interesting session, and you have gotten into lots of the details which are really necessary to pull all this off. I am not going to go into a lot of details, and some of those about scenario MIP you've addressed already anyway, but I'll just give you a kind of high level sense of where the scenario MIP process stands at the moment and what its outlook is. Doing this on the behalf of my co-chairs as well, Claudia and Detlef. So next slide. So yeah, to date, this is a summary of the steps that we've gone through. And really, I just want to emphasize that the scenario MIP process started out in the middle of 2023 with the meeting in Reading to kick off the planning. And we are now at the end there, where we are currently finalizing the draft of the paper describing the experimental design. And finalizing means we prepared a final draft. We had a final steering committee, scientific steering committee meeting to discuss the final open issues just this past Friday. We are implementing the revisions based on that meeting this week. And then sometime shortly after that, it'll go back to the steering committee just to have a final look. But sometime shortly after that, submitting to GMD. And also just to point out that in between, there were a couple rounds of review. And then GMD also, of course, has its own open review process. So there's been lots of chance for input on this, and there will be some more. Next slide. Looking at this timeline and process from a little bit of the longer term perspective, this is basically the timeline we have, and that is reflected currently in the draft of the proposal, or yeah, the experimental design. We have the period between mid 2023 and fall of 2024 now for the design. As we heard earlier, the IAM development of the scenarios has started in September, basically. And the idea in our timeline in the draft is for everything to be ready for climate model runs by September of 2025. With the idea that sometime around the beginning of 2027, results would be available for use by both, I guess all three working group communities to hopefully write some quick papers before the IPCC deadlines kick in. And of course, we don't know all the timing for the IPCC reports yet, so that's a little bit up in the air. If you just advance one, yeah. So in our assumption up till now, the idea has been to produce the final versions of the IAM scenarios around May. And then the summer has been allocated to the harmonization process. Now, it looks like from earlier presentations that people plan on that being quicker than needing the whole summer. So if that happens, then that's great. And that maybe climate model simulations could start a little earlier. I don't think there's no inclination at the moment in the IAM groups to change the current timeline. I know these things are always open to unforeseen circumstances, but the IAM groups doing the scenarios right now consider this timeline really fixed. Like, we don't consider that there's any slack in it. So the aim to complete simulations by May, I think, is going to be a solid one. Next. So just a look. You've probably had a look at these emission scenarios before. This, of course, these are just stylized versions of what the actual IAM scenarios may end up looking like. These were produced by Ben and Chris Smith, I think, who produced these and ran them through FAIR, just to have some illustrative results, kind of look ahead. And there are these 6 scenarios. The high, which we don't know how high it's going to end up being, those versions are being produced now. The medium, which is still a current policies scenario. Again, we don't know if it's going to be a constant scenario. Some of the current policy scenarios in the literature end up around roughly constant, actually somewhat declining. So that may end up looking different. The medium low is one that's specified to follow the medium out to 2040 as a delayed mitigation scenario, and then to reach net zero CO2 in 2100. And then we have these 3 low scenarios where very recently the naming convention has changed. I know that's probably not welcome news to try to have to remember something different, but in response to comments about the clarity of the naming of the 2 lowest scenarios, we have changed to calling them both very low because they're both intended to be roughly consistent with the 1.5 degree scenario in the long term and differ in their amount of overshoot. So we have put that into the naming convention. And here again, I'm showing these illustrative scenarios out to 2125, but the situation in terms of the extension of the IAM scenarios is the same as you've discussed before. It's currently 2100. If groups find themselves with lots of time between now and May, they may try to take on extending them, but I think the outlook for that is not great at the moment. Next. So here are the FAIR simulations that illustrate what kinds of global average temperature change we may be looking at for these scenarios. And in 2100, anyway, these are spanning roughly around 1.5 degrees to something like around 3.5, with the medium current policy scenario a little bit above 3. Or yeah, a little bit below 3 actually in 2100, and then a little higher later on. Next. This is the current conception of the long-term extensions, which in the proposal we are going to be requesting that they be run to 2500 if possible, realizing that a lot of teams may just run to 2300. And they range over, a very wide range in emissions, from extensions of the high to the very low high overshoot scenario, which then has a very large negative emissions sustained until 2200. Currently, the 2 that are the high priority ones that would be intended to be in the fast track simulations are the high extension, the highest one, and one of the very low overshoot scenario, which would provide an assessment of what a scenario that has the most aggressive near-term reductions and that is consistent with net zero greenhouse gases out to 2300 would look like in the long term. There is still one final discussion taking place. An option got raised on Friday to maybe have a different low scenario as the long-term extension. That will be resolved this week. So we still don't quite have this totally nailed down, but almost. Next. And finally, and I think this is all consistent with what you've talked about already. And I had my eye on these figures in the discussion today, because this is what's in our proposal right now, would be that for historical and near-term emissions in these scenarios, that we would be using historical data from the update that will occur later this year through 2023, to have 2025 as the common year for emissions for all of the IAMs, something hybrid or extrapolated, filled in between. In addition, there is going to be the guidance within the IAM groups that in the year 2030, the scenarios don't diverge too widely, so that we make sure we are in a plausible range. That plausible range is currently being estimated by a few people at PIC who have proposed a range, and we will finalize that for the proposal based on some trend extrapolation and some reasoning about potential policies. And those will be constraining emissions in the near term. And I think that's it.
Thanks a lot for that overview, Brian. I'm realizing we're 5 minutes over time, but if there's still a bit, then let's have some questions, if there is any. I'm not seeing any, so I think you were all very clear online there, Brian. Thanks.
Okay.
And over to the organizers.
Okay, well, thank you, everyone. Yeah, sorry, we ran a wee bit over, but I think it was because there's so much to discuss. So that was really interesting discussion today. So we're back again tomorrow at 9 o'clock sharp. So not too early. And it seems like the buses are not too bad because it's school holidays. So have a nice evening, everyone. Get a good sleep. And nice to see everyone online. Have we got a question?
I just wanted to maybe mention still, so there were many questions raised and many discussion points put forward. If you have any further comments, right, please do reach out to me or to the other presenters to the discussion document online as well. We'll be trying to take all of that in. And so really any input would be really helpful. We, for instance, also mentioned the impact community. I don't know if anyone is online or here. Please do reach out if you have any thoughts on the extensions to 21, 25, etc. All of the discussion points that were mentioned. Still very, very welcome. Yeah, thanks.
Yeah, and I'll try and get the recordings online tonight. So they should be there by tomorrow morning for people to have a look at. Okay, great. Thanks, everyone.